Standardization or standardization is the process of implementing and developing technical standards. Standardization can help to maximize compatibility, interoperability, safety, repeatability, or quality. It can also facilitate commoditization of formerly custom processes. In social sciences, including economics, the idea of standardization is close to the solution for a coordination problem, a situation in which all parties can realize mutual gains, but only by making mutually consistent decisions. This view includes the case of spontaneous standardization processes, to produce de facto standards. History. The implementation of standards in industry and commerce became highly important with the onset of the Industrial Revolution and the need for high-precision machine tools and interchangeable parts. First attempts. Henry Maudslay developed the first industrially practical screw-cutting lathe in 1800. This allowed for the standardization of screw thread sizes for the first time and paved the way for the practical application of interchangeability to nuts and bolts. Before this, screw threads were usually made by chipping and filing. Nuts were rare. Metal screws, when made at all, were usually for use in wood. Metal bolts passing through wood framing to a metal fastening on the other side were usually fastened in non-threaded ways. Maudslay standardized the screw threads used in his workshop and produced sets of taps and dies that would make nuts and bolts consistently to those standards, so that any bolt of the appropriate size would fit any nut of the same size. This was a major advance in workshop technology. National standard. Maudslay's work, as well as the contributions of other engineers, accomplished a modest amount of industry standardization. Some companies' in-house standards spread a bit within their industries. Joseph Whitworth's screw thread measurements were adopted as the first national standard by companies around the country in 1841. It came to be known as the British Standard Whitworth, and was widely adopted in other countries. This new standard specified a 55 degrees thread angle and a thread depth of 0.640327 p and a radius of 0.137329 p, where p is the pitch. The thread pitch increased with diameter in steps specified on a chart. An example of the use of the Whitworth thread is the Royal Navy's Crimean War gunboats. These were the first instance of mass production techniques being applied to marine engineering, with the adoption of BSW by British railway lines, many of which had previously used their own standard both for threads and for bolt head and nut profiles, and improving manufacturing techniques. It came to dominate British manufacturing. American Unified Course was originally based on almost the same imperial fractions. The unified thread angle is 60 degrees and has flattened crests. Thread pitch is the same in both systems except that the thread pitch for the 1/2 in bolt is 12 threads per inch in BSW versus 13 TPI in the UNC National Standards Body. By the end of the 19th century, differences in standards between companies was making trade increasingly difficult and strained. For instance, an iron and steel dealer recorded his displeasure in the Times. Architects and engineers generally specify such unnecessarily diverse types of sectional material or given work that anything like economical and continuous manufacture becomes impossible. In this country, no two professional men are agreed upon the size and weight of a girder to employ for given work. The Engineering Standards Committee was established in London in 1901 as the world's first national standards body. It subsequently extended its standardization work and became the British Engineering Standards Association in 1918, adopting the name British Standards Institution in 1931 after receiving its Royal Charter in 1929. The national standards were adopted universally throughout the country, and enabled the markets to act more rationally and efficiently, with an increased level of cooperation. After the First World War, similar national bodies were established in other countries. The Deutsches Institut für Normung was set up in Germany in 1917, followed by its counterparts. the American National Standard Institute and the French Commission Permanente de Standardization, both in 1918. International standards. By the mid to late 19th century, efforts were being made to standardize electrical measurement. Lord Kelvin was an important figure in this process, introducing accurate methods and apparatus for measuring electricity. In 1857, he introduced a series of effective instruments, including the quadrant electrometer, which covered the entire field of electrostatic measurement. He invented the current balance, also known as the Kelvin balance or ampere balance, for the precise specification of the ampere, the standard unit of electric current. Another important figure was R.E.B. Crompton, who became concerned by the large range of different standards and systems used by electrical engineering companies and scientists in the early 20th century. Many companies had entered the market in the 1890s and all chose their own settings for voltage, frequency, current and even the symbols used on circuit diagrams. Adjacent buildings would have totally incompatible electrical systems simply because they had been fitted out by different companies. Crompton could see the lack of efficiency in this system and began to consider proposals for an international standard for electric engineering. In 1904, Crompton represented Britain at the Louisiana Purchase Exposition in St. Louis as part of a delegation by the Institute of Electrical Engineers. He presented a paper on standardization, which was so well received that he was asked to look into the formation of a commission to oversee the process. By 1906 his work was complete and he drew up a permanent constitution for the first international standards organization, the International Electrotechnical Commission. The body held its first meeting that year in London, with representatives from 14 countries. In honor of his contribution to electrical standardization, Lord Kelvin was elected as the body's first president. The International Federation of the National Standardizing Associations was founded in 1926 with the broader remit to enhance international cooperation for all technical standards and specifications. The body was suspended in 1942 during World War II. After the war, ISA was approached by the recently formed United Nations Standards Coordinating Committee with a proposal to form a new global standards body. In October 1946, ISA and UNSCC delegates from 25 countries met in London and agreed to join forces to create the new International Organization for Standardization. The new organization officially began operations in February 1947. In general, each country or economy has a single recognized national standards body. Examples include ABNT, AENOR, AFNOR, ANSI, BSA, DGN, DIN, IRIM, JISC, CATS, SABS, SAC, SCC, CIS. An NSB is likely the sole member from that economy in ISO. NSBs may be either public or private sector organizations, or combinations of the two. For example, the three NSBs of Canada, Mexico and the United States are respectively the Standards Council of Canada, the General Bureau of Standards, and the American National Standards Institute. SCC is a Canadian Crown Corporation, DGN is a governmental agency within the Mexican Ministry of Economy, and ANSI and AENO are a 501 non-profit organization with members from both the private and public sectors. The determinants of whether an NSB for a particular economy is a public or private sector body may include the historical and traditional roles that the private sector fills in public affairs in that economy or the development stage of that economy. Usage. Standards can be de facto standards, which means they're followed by informal convention or dominant usage. De jure standards, which are part of legally binding contracts, laws or regulations. Voluntary standards, which are published and available for people to consider for use. The existence of a published standard does not necessarily imply that it is useful or correct. Just because an item is stamped with a standard number does not, by itself, indicate that the item is fit for any particular use. The people who use the item or service or specify it have the responsibility to consider the available standards, specify the correct one, enforce compliance, and use the item correctly. Validation and verification. Standardization is implemented greatly when companies release new products to market. Compatibility is important for products to be successful. This allows consumers to use their new items along with what they already own. Social science in the context of social criticism and social science. Standardization often means the process of establishing standards of various kinds and improving the efficiency to handle people, their interactions, cases, and so forth. Examples include formalization of judicial procedure in court, and establishing uniform criteria for diagnosing mental disease. Standardization in this sense is often discussed along with such large-scale social changes as modernization, bureaucratization, homogenization, and centralization of society. Information exchange in the context of information exchange. Standardization refers to the process of developing standards for specific business processes using specific formal languages. These standards are usually developed in voluntary consensus standards bodies such as the United Nations Center for Trade Facilitation and Electronic Business, the World Wide Web Consortium W3C, the Telecommunications Industry Association, and the Organization for the Advancement of Structured Information Standards. There are many specifications that govern the operation and interaction of devices and software on the Internet, but they are rarely referred to as standards, so as to preserve that word as the domain of relatively disinterested bodies such as ISO. The W3C, for example, publishes recommendations, and the IETF publishes requests for comments. However, these publications are sometimes referred to as standards. Customer service in the context of customer service. Standardization refers to the process of developing an international standard that enables organizations to focus their attention on delivering excellence in customer service, whilst at the same time providing recognition of success through a third-party organization, such as the British Standards Institution. An international standard has been developed by the International Customer Service Institute. Supply and materials management in the context of supply chain management and materials management. Standardization covers the process of specification and use of any item the company must buy and/or make allowable substitutions, and build or buy decisions. Defense in the context of defense. Standardization has been defined by NATO as the development and implementation of concepts, doctrines, procedures and designs to achieve and maintain the required levels of compatibility, interchangeability or commonality in the operational, procedural, material, technical and administrative fields to attain interoperability. Process. The process of standardization can itself be standardized. There are at least 4 levels of standardization: compatibility, interchangeability, commonality and reference. These standardization processes create compatibility, similarity, measurement and symbol standards. There are typically 4 different techniques for standardization: simplification or variety control, codification, value engineering, statistical process control. Types of standardization process: emergence as de facto standard, tradition, market domination, etc. Written by a standards organization. In a closed consensus process. Restricted membership and often having formal procedures for due process among voting members in a full consensus process. Usually open to all interested and qualified parties and with formal procedures for due process considerations. Written by a government or regulatory body. Written by a corporation, union, trade association, etc. Effects. Standardization has a variety of benefits and drawbacks for firms and consumers participating in the market, and on technology and innovation. Effect on firms. The primary effect of standardization on firms is that the basis of competition is shifted from integrated systems to individual components within the system. Prior to standardization, a company's product must span the entire system because individual components from different competitors are incompatible. But after standardization, each company can focus on providing an individual component of the system. When the shift toward competition based on individual components takes place, firms selling tightly integrated systems must quickly shift to a modular approach, supplying other companies with subsystems or components. Effect on consumers. Standardization has a variety of benefits for consumers, but one of the greatest benefits is enhanced network effects. Standards increase compatibility and interoperability between products, allowing information to be shared within a larger network and attracting more consumers to use the new technology, further enhancing network effects. Other benefits of standardization to consumers are reduced uncertainty, because consumers can be more certain that they are not choosing the wrong product, and reduced lock-in, because the standard makes it more likely that there will be competing products in the space. Consumers may also get the benefit of being able to mix and match components of a system to align with their specific preferences. Probably the greatest downside of standardization for consumers is lack of variety. There is no guarantee that the chosen standard will meet all consumers' needs or even that the standard is the best available option. Another downside is that if a standard is agreed upon before products are available in the market, then consumers are deprived of the penetration pricing that often results when rivals are competing to rapidly increase market share in an attempt to increase the likelihood that their product will become the standard. It is also possible that a consumer will choose a product based upon a standard that fails to become dominant. In this case, the consumer will have spent resources on a product that is ultimately less useful to him or her as the result of the standardization process. Effect on technology. Much like the effect on consumers, the effect of standardization on technology and innovation is mixed. Increased adoption of a new technology as a result of standardization is important because rival and incompatible approaches competing in the marketplace can slow or even kill the growth of the technology. The shift to a modularized architecture as a result of standardization brings increased flexibility, rapid introduction of new products, and the ability to more closely meet individual customers' needs. The negative effects of standardization on technology have to do with its tendency to restrict new technology and innovation. Standards shift competition from features to price because the features are defined by the standard. The degree to which this is true depends on the specificity of the standard. Standardization in an area also rules out alternative technologies as options while encouraging others.